Welcome to Tech Unplugged. Today, we're really digging into something fascinating. AI agents, specifically how they're starting to work together.
Yeah, it's a huge area. You shared some great research, and we're going to try and unpack it all.
Exactly. So our goal today is to explore this idea of AI collaboration, look at the protocols making it happen, the security side of things.
And, of course, how these systems might actually scale up.
Mhm.
We'll look at different ways people are thinking about this, maybe some real-world examples, too.
Think of it as your guide to, well, what feels like the next level of AI, right?
Definitely.
Okay, so let's get into this idea of autonomous agents cooperating. It sounds like a pretty big jump from just, one AI using a few tools.
Oh, it's a massive step.
Yeah.
We're seeing these protocols actually starting to pop up, designed just for this agent-to-agent stuff.
Moving towards that agentic internet idea.
Exactly, that term, yeah.
Yeah.
An interconnected web of AI. And it's not just about making things easier. It could really change how AI gets built. Smaller, specialized agents could just plug in.
Interesting. And the two big ones mentioned are Google's A2A, agent to agent.
Right, A2A, and Anthropic's MCP, the Model Context Protocol.
Okay, so what's the deal with these? What makes them stand out?
Well, it's interesting because they tackle it slightly differently. A2A seems to be aiming for a really broad, open standard.
Open standards, so like anyone can use it.
That's the goal.
Yeah.
Agents from different companies built on different tech could still talk and coordinate actions. Universal interoperability, basically.
Like a universal translator, but for AI, how does it actually work under the hood?
It uses a client-server setup. Agents have these things called agent cards.
Agent cards, like business cards.
Sort of, yeah. They're JSON files, just a standard way to structure data that describe what the agent is, what it can do, its security needs, stuff like that.
Okay.
So if one agent, the client, needs something done, it can look at these agent cards to find another agent, the server, that has the right skills.
Got it. Finding the right specialist. What about the actual talking part?
That happens inside tasks. These tasks have a life cycle. Submitted, working, done, failed. And the messages they send back and forth have parts.
Parts?
Yeah, like text or files or even bits of user interface. So they can share info, but also figure out how best to show it to a human user, if needed.
And Google's aiming for a stable version soon.
Later in 2025, yeah. Version
Good.
1.0. So they seem serious about pushing it.
Okay, A2A helps different agents chat. Where does Anthropic's MCP come in?
MCP feels a bit more focused on giving an individual AI model immediate info, stuff beyond its training data.
So making the one agent smarter, basically.
Kind of, yeah. Giving it access to databases, maybe special services, letting it save info, or even trigger actions outside itself.
So A2A is about talking between agents. MCP is about giving one agent better access to the world.
Exactly. MCP also uses a client-server model, supports different ways to communicate, like standard I/O or server-sent events or real-time updates. And Google even says A2A and MCP are complementary.
Complementary, how so?
Well, you could use MCP to make an agent really capable, give it lots of tools and data access, and then use A2A so that super capable agent can go collaborate with other capable agents.
Ah, okay. That makes sense. It's interesting, too, that this Pistoia alliance is involved. They're focused on pharma, right?
Yeah, pharmaceuticals, drug development, they're working on their own agent communication protocol and standards.
Why would pharma specifically need this?
It really points to the core issue. AI tools built in silos. In pharma, you might have one team build an AI for analyzing trial data, another for molecule simulation, but they don't talk.
Ah, I see. So they can't work together.
Right. Pistoia sees that if they define roles and communication rules, they can connect these separate AI applications and really speed up drug discovery, break down those walls.
It really does come down to unlocking potential by letting them team up. Can you give some, concrete examples of how this might work?
Sure. Think about hiring someone. Candidate sourcing. Instead of one person or one AI doing it all, you could have a specialized agent finding candidates, hand them off to another agent that does initial interviews, maybe a third does background checks, all coordinated.
Wow, okay. That does sound way more efficient.
Totally. And we're seeing weirder, more creative ideas too, like that Bachelorette game example.
The what now?
Yeah, AI agents playing a game, negotiating marriage contracts.
Marriage contracts between AIs.
Right. But the goal is to get access to the other agent's unique data, maybe to train new AIs. It just shows the kind of complex, unexpected interactions that could happen.
Okay, the potential sounds huge. But it can't be that easy. What are the big hurdles to making this work at scale?
You're absolutely right. There are definitely challenges. Scalability is a major one.
Meaning just handling lots and lots of agents.
Yeah, managing the load. All that
Yeah.
communication, the processing power needed, the memory, it gets complicated fast. You need things like dynamic load balancing, maybe decentralized decision-making.
And I guess getting agents built by different people on different systems to actually understand each other, that's got to be tough.
That's interoperability. Super critical. You need those standard protocols like A2A aims to be so agents aren't just, speaking different languages.
Right. And within a system, how do you decide which agent does what? Task allocation.
Yeah, that needs optimizing. You want the best agent for the job, right? People
Yeah.
are looking at things like auction systems where agents bid on tasks,
Oh, interesting.
or using machine learning to adjust assignments on the fly based on how agents are performing, making sure everyone's pulling in the same direction for the system's goals.
And with all this autonomy, trust must be a massive issue. How do you trust an AI agent you're interacting with?
Absolutely crucial. We need ways to build that trust, maybe frameworks using blockchains for a reputation system.
Blockchain. How would that work?
Well, you could track an agent's history, its past transactions, how fair its deals were, make reputable agents, more desirable partners. It creates an incentive to play fair.
That reputation system leads right into this other fascinating bit. Agents exchanging intellectual property, like buying and selling knowledge.
Exactly. That's the idea behind this ATC-PIP protocol, Agent Transaction Control Protocol for Intellectual Property.
Okay, break that down. ATC-PIP.
It's a framework designed to be trustless using blockchain, where agents can initiate deals, trade, borrow, even sell contracts for things like data, algorithms, content.
So the blockchain provides the trust layer, the immutable record.
Precisely. It makes the whole process transparent and tamper-proof, which you definitely need if agents are doing deals autonomously.
So agents could literally become independent economic actors trading IP.
That's the vision. These contracts are programmable. They execute on the blockchain, but they also have this idea of a legal wrapper.
Legal wrapper, trying to give agents legal standing.
Kind of aiming that way, yeah. To make the contracts enforceable, even off-chain. Imagine an agent just deciding to sell its training data set or license out its cool new algorithm.
Wild. How does a typical deal work using ATC-PIP? What's the flow?
It usually starts with one agent requesting some info, some IP. The owner agent then puts together license terms, maybe using a standard like Story's PIL, Programmable IP license.
DIA.
Yeah, a template for these kinds of licenses. Then there might be negotiation back and forth, automated counteroffers until they agree.
Okay.
Then the license gets minted on the blockchain, creating a unique digital token representing the deal. Payment happens, the IP gets delivered, and maybe there's a final confirmation step.
And these licenses can adapt. You mentioned dynamic licensing.
Right. The terms aren't necessarily fixed. They could be adjusted for each specific request. And that on-chain license token is the proof, the immutable record of the agreement.
What does that license token actually record? The metadata.
Key stuff. License ID, who issued it, who holds it, dates, version number, and importantly, a link to the full legal terms.
What kinds of things could this be used for? Real-world examples.
Well, an agent could license a data set to fine-tune itself autonomously.
Yeah.
Or that marriage contract game, the contract could be the license token.
Ah, the token represents the right to access the data.
Exactly. Or think about financial trading algorithms. You could have multi-hop profit sharing.
Multi-hop. What's that?
Imagine Agent A licenses an algorithm from Agent B, but Agent B's algorithm uses a component licensed from Agent C.
Okay, a chain of dependencies.
Right. ATC-PIP could automatically ensure that Agent C gets a cut, a royalty, every time Agent B sublicenses the main algorithm to someone like Agent A. It creates this fluid knowledge economy.
That's potentially revolutionary for how IP is managed. But okay, more agents, more autonomy, more interaction means more security risks.
Absolutely. Big time. The attack surface just gets way bigger. And one specific threat that comes up is tool squatting.
Tool squatting, like domain squatting, but for AI tools.
Yeah, pretty much. It's deceptively registering or representing a tool or even another agent to trick others.
How would someone do that in these A2A or MCP systems?
Several ways. An attacker could spoof an agent card in A2A, pretending to be a trusted agent or having capabilities it doesn't possess.
So lying on its resume, basically.
Exactly. Or they could try to poison the discovery process, injecting fake listings so their malicious agent gets picked for a job. Or just tamper with the descriptions of legitimate tools.
And for MCP.
They could set up a fake MCP server pretending to be a legitimate database or service, hoping an agent connects to it.
And the point of all this is?
To exploit trust. If they trick another agent, they could hijack tasks, intercept data, maybe modify results, or just steal sensitive information the other agent sends them.
That sounds really bad. So how do we defend against this? What are the ideas?
A key proposal is a tool registry system. Think of it like a secure, verified directory.
Managed by?
Admins, probably. They'd control the registration and verification of all agents and tools allowed in the system. Discovery would happen only through this central registry.
Like a walled garden, almost.
A bit, yeah,
Oh,
but
yeah.
with a zero-trust approach baked in. You'd have strict access policies based on verified identities, who can talk to whom, who can use what tool.
Okay, so registration and access control. What else?
A dynamic trust score for tools.
A score. Based on what?
Things like, is it using the latest software version? Does it depend on libraries with known vulnerabilities? How well is it maintained? It helps agents assess risk before using a tool.
And credentials. How do agents prove who they are securely?
That's where just-in-time, or JIT, credential provisioning comes in. Instead of long-lived passwords or keys, the system issues short-lived access tokens. Only was needed for a specific interaction. Minimizes the window if a credential gets stolen.
It really feels like the old ways of thinking about security, designed for humans logging in, just don't cut it here.
That's a really important point. AI agents don't behave like humans. They might rely on stale credentials for ages, making them targets. So enterprises really need to look at AI-specific identity and access management IAM solutions.
IAM for AI.
Yeah, better authentication, better authorization, better monitoring, specifically designed for autonomous agents, especially when they handle sensitive stuff. Even ensuring retrieval augmented generation, RAG.
RA, that's when AI pulls info to answer questions.
Right. You need to make sure the AI only pulls documents the user actually has permission to see, not just anything it can find. Authorization has to follow the user's rights, even when an AI is acting for them.
So security is multi-layered. Registry, trust scores, JOT credentials, AI-specific IMM, RAG authorization. Wow. Okay, what about the other big challenge? Scalability. Keeping things running smoothly as you add thousands, maybe millions of agents.
Yeah, scalability is always the elephant in the room with distributed systems. It's about maintaining performance, speed, reliability as things grow, managing load and complexity,
Load meaning.
memory usage, CPU cycles, network communication,
Yeah.
just the resources needed to keep all those agents running and talking.
Does it matter what kind of agent it is?
It does. You have reactive agents. They only wake up and do something when they get a message. They mostly stress memory. You need to store info about them all.
Okay. And the other kind?
Proactive agents. They initiate tasks themselves. They need memory and significant CPU power. For those, you almost certainly need to distribute the load across many machines. And crucially, message passing needs to be fast and reliable. Otherwise, the whole thing descends into chaos.
Can the security itself cause scaling problems, all that verification and encryption?
Oh, definitely. Computational complexity is a factor.
Yeah.
Public key cryptography, which is great for security, can be much heavier on processing time than symmetric key crypto, especially as the number of messages skyrockets.
So there's a trade-off between security strength and performance at scale.
Often, yes. And just finding the right agent or tool in a massive system, that search and matching part, can become a real bottleneck. Sometimes you need very specific solutions for that part, depending on the application.
Does how you organize the agents matter for scaling?
Hugely.
Mm.
A really simple setup, like agents just posting jobs and others taking them, like a basic market, that might not scale well. It could just get overwhelmed. More complex structures might work better, maybe agents forming teams, or intermediary agents managing workflows.
But that sounds like it adds its own complexity.
It does. More communication overhead, maybe the agents need to be smarter, have better inference capabilities. The ideal might be adaptable organizations systems where agents can dynamically change how they're structured based on the current load. Optimize on the fly.
So it's this constant balancing act, functionality, security, scalability, they all pull on each other.
That's it, exactly. Developing these protocols like A2A and ATCP/IP, thinking about security with things like tool registries, figuring out scalable architectures, it's all part of building the foundation.
The potential seems enormous, but getting it right requires tackling all these challenges head on.
Absolutely. But it feels like the direction things are heading. A much more interconnected future for AI.
Okay, so let's try and boil this down. What does all this mean for you listening right now? Well, as AI gets woven deeper into everything we do, having these agents work together smoothly and safely, that's going to be a huge driver.
Yeah, think about automating really complex workflows, things that involve multiple steps or departments today, or creating totally new kinds of services we haven't even imagined yet. That collaborative power is key.
And where it gets really interesting, like you said, is thinking about specific industries: healthcare, finance, logistics. Imagine multiple AIs coordinating really complex operations way faster than humans could.
Or those new economic models, right?
Right.
Agents autonomously buying and selling data, algorithms, IP. It could change how value is created and exchanged online.
So the bottom line seems to be developing these standard ways for agents to talk, like A2A, and strong security, like tool registries and AI-specific IAM, isn't just, a technical puzzle for engineers.
No, it's absolutely fundamental. It's building the infrastructure for a smarter, more interconnected world. So
Hmm.
definitely keep an eye on how these protocols evolve and how companies start building these secure agent systems. Huge potential for breakthroughs here.
Which leads to a final thought, maybe something for you to chew on. As these agents get smarter and more connected, what new possibilities does that open up in your own field or even your daily life?
And what are the new concerns? What safeguards do we need?
Yeah.
It's a massive topic, lots to think about. We really encourage you to look more into some of the concepts we touched on.
Definitely lots to explore there. Thanks for listening to Tech Unplugged for this deep dive.